Hi, my name is Avril Sorter and you're listening to CCNA Wireless. And in this lesson we're going to look at wireless clients that are available from Cisco. So when you look at a laptop or a computer that's running Windows, you will configure the wireless client capabilities using the Windows 0 configuration. Now you can actually turn this off and use the application that actually comes with the wireless radio that's integrated into your laptop. But most people will just use the Windows 0 configuration utility if they're running the Windows operating system. And it's very important that when it comes to wireless that you only manage it with one application. So if you're going to use another utility, you want to make sure that you turn this one off. Now the Windows 0 configuration utility is fairly straightforward. It scans the RF and finds all of the access points and then displays those access points that it's been able to find. You can then see with the little bar next to the name how strong the signal is, and the stronger the signal is, then the better the connection and the higher the data rates that you'll be able to attain when connecting to that access point. It'll also tell you about its security and how the security is set, whether it is set with WPA2, WPA, WEP, or no security. The beauty of this is it's a fairly simple tool and it's on by default, and like I said, you can turn it off, and if you want to use another program you need to turn it off, and the way you do that is you go into the Windows services and that's where you'll disable it. If we now look at Mac based clients, so this is the Apple Mac OS environment, the wireless settings you can change by going into System Preferences, and System Preferences is actually an application. Just like with the Windows client, it's a very simple to use application and it is on by default. Now configuring Wi-Fi on a Linux client is not as easy as it is with a Windows or a Mac computer. But there are a number of utilities that are available, and it does depend on which Linux OS you're actually running. The one that we're showing here is called Network Manager, and it was originally released through Red Hat. And Network Manager supports not only Wi-Fi but also Ethernet connections as well as PPP connections. And of course it's not only computers now that you're looking to connect, but it's also tablets and smartphones. And if you have an iPhone or an iPad, then you'll be using the iOS Apple operating system. Typically with these devices you'll go in and you'll configure it for the first time you're connecting to that Wi-Fi network, be that your home network, your corporate network, or your public network. But after that it keeps the configuration just like with the other utilities, and just like with the other utilities you can prioritize which network you want to connect to. So these devices continue to get simpler and simpler and keep it very, very simple for the user to connect. The Android also very straightforward and simple to connect. You would go into your device, you would make sure that Wi-Fi was turned on, you would then look at the different wireless networks that have been detected, you would click on the SSID and then you can go ahead and connect. You can set up notification for it to find open Wi-Fi networks, which is great if you're traveling, and then you can go in and actually configure different wireless networks, so key in the passwords, etc., so it'll automatically find certain profiles. The bottom line on all of these devices is getting pretty easy, regardless of what operating system you've got, to find the Wi-Fi and to connect to it, and they're all pretty much operating in the same way, even though the GUIs are slightly different. Now remember what I said at the beginning, if you're going to use the tool that's specific for the Wi-Fi card or silicon that you have already integrated into your device, you can do that. And I have several laptops and they've all got the Intel ProSet wireless tools in there, and so I can get to those and use them. And the way you get them on your Windows computer is you would go into the control panel and select Network and Internet, and the Network and Sharing Center. You'll see that you can also get to the Intel My Wi-Fi technology, or the Intel ProSet/wireless tools. They're actually displayed in the corner of that screen. A lot of people don't even notice it. My main advice here is make sure you turn and disable the Microsoft utility before you actually utilize a vendor's tool. Vendors' tools tend not to be as simple as the tools that are integrated in the operating system. However, the advantage of them is that you can do a little bit more. You can get in and configure them a little bit differently, set up different profiles, etc. So it really does depend on your preference, what you're trying to do in terms of managing clients and connecting with clients to your Wi-Fi network. So I wanted to demonstrate for you how to configure a client, and the Windows clients are the ones that's most widely deployed in enterprise environments today. So I'm going to use a Windows client. I'm going to use my Acer laptop, and my Acer laptop has an Intel Wi-Fi card in it. So in this demo, I want to take you through configuring a Windows client, and we'll take a look at some of the features and the capabilities. So here is my network, and you can see that I'm currently connected to Avril's network. I'm going to select the Open Network and Sharing Center, and then I'm going to select Manage Adapter Settings. This then brings me in and I can see my wireless adapter. I'll right click that. Let's take a look at the status first. You can see that I'm connected and my data rates are currently over 100 megabits per second. We come across and select wireless properties. One of the things I want to show you is that here, if I select the Enable Intel Connection settings, it brings up this Configure button, which then I can select, and you'll notice here Cisco options. So this is part of the CCX certification that Cisco offers, and you can see if I select this, then I can enable radio measurements. So what I'm doing is I'm enabling this client to take measurements at the request of a Cisco wireless LAN controller, and then that Cisco wireless LAN controller can make decisions regarding what the best channel and the power levels are for the different access points. So this is turning on my client and making it willing to make radio measurements when it's requested to do that. I cancel out of that. The other thing that's in this tab here is in security. So let's take a look at that. This is where you would set up the security for your client. And you can see I can say no authentication. I can have shared, which is using the private shared key technology, where I would key in a key, password if you like, and that's known to my client. It's also known to the access point or the authentication server. And if that will be used then to make sure that it's me that's connecting to the network, I can use WPA2, WPA2 Enterprise. You can see the 8021X as well as an Intel Pacific protocol called CCKM for connecting to the enterprise. I can select my encryption level, so I can use TKIP or AES, and here's where I'd put in my personal network key, because here in my home environment I'm using WPA2. Cancel out of that. Okay, now what I wanted to do now was to take a look at properties. And what we want to do here is we want to take a look at the properties associated with my wireless card adapter from Intel. And again, different vendors, different products, so the interface will be slightly different. So I'm going to select Configure. Bring that down a bit so we can see it. And you can see here now I'm using my wireless adapter from Intel. And here I can click on Advanced, and you can see the settings. And so if I look here, operating in the 2.4 gigahertz band, 20 megahertz only, I can set it to auto. If I set it to auto, if there is an 802.11n access point that's talking in a 40 megahertz channel, I will now use 40 megahertz to communicate with it rather than 20, which will improve my data rate. I can come here and do the same thing for the 5 gigahertz band. Here's my 802.11n mode of operation, and this says, do I want to operate with my N radio? And so in some environments I might actually not want you to communicate with N, so I can disable that. And again, these settings are different for different vendors. Here's my ad hoc mode, and you can see I'm connected in ad hoc on channel 11. Here's my quality of service, and you'll see here that WMM is actually disabled, and so I could go ahead and enable that if I wanted to connect to a WMM enabled access point and do quality of service over the radio connection. Here's Bluetooth, and that just means if I want to use Bluetooth as an alternative MAC and PHY, that's what AMP stands for. The fat channel intolerant is an interesting bit. If you're not aware of this, if I set that bit, so if I set it to enable, what will happen then is it will prevent the access point for communicating in a 40 megahertz channel. So I'm basically saying, hey, I cannot operate in a 40 megahertz channel. You have to support a 20 megahertz channel. Here's mixed mode of operation. So this is if I'm operating with legacy ABG equipment. And here you can see in this case I've got it set up to do a clear to send, but I could set it up to do a request to send, clear to send. Typically you just leave it as this one because I've got a fairly clean, not very busy RF environment. Here's if I have a preferred band that I want to connect on, and you would set this one, for instance, if you were wanting to take all your voice devices and have them operate in the 5 gigahertz band, then you would set a band preference. Roaming aggressiveness, literally my aggressiveness in roaming. So if I have it high, what's going to happen is I'm going to be much quicker at roaming to another access point. And you might say, well, why don't I do that? It's actually not that good to have it high, because what can happen if you have it high is you start flip-flopping between access points. And so you want to make sure that's not set too high. Medium or a bit lower is normally what you want to do. And again, it's a setting that you can set. And if you notice your clients flip-flopping between access points, you should definitely check this setting as to how aggressive they're being. The transmit power, again, you will control that in the beacon to say what is my maximum power level that I can transmit at, but a client can set that to say I want to transmit at the highest. If I want to conserve battery power, then I can reduce that down and conserve battery on my device. And then I have the last thing is the wireless mode, and so here I have the ability to say, hey, I just want to operate as an A device, a B device, etc. So it's a matter of which mode of operation do I want to operate in. Over here you can see the driver, and you can see the driver date, and you always want to make sure you're running the last updated driver. Now, in my case, my drivers are updated through Windows Update service, but many times some of your client devices may not include a radio that's part of the Windows Update program, and so it's quite possible your drivers get out of date. So that can cause you some client problems, connectivity problems. Not providing very much detail, but is here for the detail, and you can take a look at what is it you want to see. So I can come down and say, okay, let me look at the capabilities. Okay, and then it can say to me, okay, then I know now where to find the capabilities of this radio. And then, of course, power management. You want to conserve power if you're on a laptop or a handheld device. On a desktop, you might, for instance, want to take that off. So we have now looked at all of the Intel settings, and again, they're different for different manufacturers. And so play with your own device, become familiar with this. And the main thing of looking at this is when you're troubleshooting client connectivity problems, you want to make sure you understand the different attributes in the client. So the last thing I just wanted to show you is here are some additional features and capabilities that are provided by Intel. And so here you can see the Pro Set, the wireless tools. I've also got my Wi-Fi technology. Most of the time you wouldn't use these, but they do have some additional features. And so you can see here that by using the vendor specific facilities, there's a lot of different things that you can do. Now, the other thing you should be aware of is that many users will get in and play with these settings. And so typically what you want to do is set up a wireless profile to connect to your network. And the first thing you want to do is update that profile where you can change all the settings back to what they should be if a client has problems connecting to your wireless network. So you can see there's a lot of different things that they can do here. In larger deployments, you'll actually drive a lot of these settings driven down by a security profile. Perhaps you're using maybe the Microsoft Active Directory service, or you're using the Cisco ASA service, and then you can drive these settings to make sure that your subscribers don't go in and change the settings and therefore find themselves unable to connect to the network. I hope you found this demo valuable, and I would encourage you to take a look at different clients, play with the different utilities, because the more you know about these settings, the easier it's going to be for you to configure and work in the wireless network arena. So in this lesson, we want to take a look at the wireless drivers and chipsets that are out there. So in the demo, we talked about the one that's on my Acer laptop, but there are a lot of manufacturers out there. A couple of the major Wi-Fi silicon providers, not only is Intel, but would be Broadcom and also Atheros, which was acquired a while back by Qualcomm. Now you saw from the previous demo there's a lot of features and capabilities that I can set, and if you know the manufacturer of your silicon, it's much easier to troubleshoot if you're having client connectivity problems. And bear in mind that silicon is not only in your client device, it's also the silicon that's in your access point. Now on the next few slides I have some tables that just show you the different vendors and the different models that are out there. This isn't meant to be an inclusive list. This is just meant to sample so you can see how many there are. So this is Atheros. Now we're looking at Broadcom, and you can see a huge number of options there. Some of them are for integration as a system on a chip, others are more standalone. Here you can see Intel's, and in the demo I did, I have an Intel 6230, which is the second line on here, which supports 802.11n dual band. In here on this slide, I'm showing you some of the smaller, less well-known silicon providers. And in this case, you can see Metalink develop their Wi-Fi, and they provide it in an adapter format as a card bus PCI format. And you can see Ralink, they actually provide a Maxa Wi-Fi beam, which actually is a 3x3 MIMO, and was one of the first ones in the market. Now, hardware devices that are placed on a computer, and it doesn't matter whether you're talking desktop, laptop, tablet, when you place a hardware device on that computer, it needs a driver. And so the communication between the OS and the driver is needed to run that piece of hardware. And the driver is provided by the manufacturer of the hardware. Now, device manufacturers routinely update their drivers. If you have a new piece of silicon, it quite often can have some problems with it, and so therefore you want to check to make sure that it's updated. Sometimes, you can get some security vulnerabilities as well, so always a good idea to do this, not only if you're having problems, but just as a routine part of your maintenance of your network. And again, cannot stress how important this is. There are various ways you can do this. Most of your drivers would be updated just as part of Windows Update if you're on a Windows platform. Other platforms, you may have to go to the manufacturer's website in order to get the latest driver. You can then update that driver by touching every laptop, or you can drive that driver down when users first connect to the network. And of course, you always want to test the driver before you go ahead and deploy it on your user's equipment, just in case there is a problem that's not been reported yet on that driver. So Cisco has some wireless client adapters, and those client adapters require firmware and drivers and other utilities, just like we've seen that the other manufacturers provide. And for Cisco, that's called the Cisco AirNet Desktop Utility, and that's what we're going to talk about now. Now, these products interwork with Windows operating system, but the older versions, the XP and the Vista, not Windows 7. The formats of these adapters are the older formats, and so a card bus that you've got pictured here, or a PCI adapter slot format. So the installation of the Internet Client Adapter actually includes the firmware, the NDIS driver, and the utilities. Here we're looking at the AirNet Desktop Utilities, and there's two components of it: an administration utility and a site survey utility. When you run the wizard, it'll automatically install these components for you, and that's reflected in the picture that you can see here on the right. If you are doing this install, please make sure you put in the Cisco client adapter card into your machine, into your Windows machine, before you actually start the installation wizard. After you've installed it and you want to use it, it's very important that you disable the Windows 0 configuration utility. You only want to run one application. You would then go ahead and configure the utility much like you did with the other vendor equipment. You would create a profile for connecting to the wireless network. You'd give it a profile name. You'd define your security settings, etc. Your preferred access points that you want to connect to. And then the AirNet utility gives you two configuration tabs where you can nip in there and you can set up the global settings for the card itself, and then set up your Pacific wireless settings under the Profile Management tab. The site survey utility is the one where it goes out and sniffs for access points, and so it can reveal to you what access points, what the SSIDs it found. It'll show you what you're currently associated with. It'll give you indication of the signal strength and your current data rate that you're communicating at. A little bit like the Intel utility we saw, you can also go in and see some statistical information, and that can be useful if you're troubleshooting a connection to see if you're not connecting with the right signal strength or something like that. Even though in this example I've taken you through the Windows operating system, the Cisco AirNet desktop utility does actually also run on the Windows embedded platform. It runs on the Mac OS, Linux, and if you're inclined, the Microsoft DOS environment as well. So Cisco has introduced a product called Cisco AnyConnect, and this has replaced the older Cisco Secure Services client. And the reason why Cisco replaced it with this product is increasingly in our corporate environments, in our enterprise environments, people are bringing in their personal devices and wanting to connect to the corporate network. So that would be things like tablets, smartphones. And so it's important to rethink security from a client perspective when the actual client device is now owned by an individual and not by the company. So when we look at the Cisco AnyConnect, or if we look at the Cisco Mobility Security Solution, it really consists of three components. One is the client software, the AnyConnect Secure Mobility Client that will be deployed in any client device that wants to connect to the enterprise network. Indeed, you can actually go to the Apple App Store and download the Cisco AnyConnect client for your iPhone or iPad. Then there is the Cisco ASA appliance, and so that's deployed in the network. Now there's different types of appliances, and so the functionality can be different, but this provides basically protection of your network. So it has firewall, VPN capabilities, also intrusion prevention capabilities, where it's going to sniff the packets and make sure what's going across the network is not suspicious. And then you have the web appliances, which again is another perimeter appliance to defend against spyware and malware coming in from these new mobile devices into the corporate network. So what this has enabled you to do is to enable those private devices to be able to connect securely to the corporate network and not to expose the corporate network. So this client supports Windows XP, Windows Vista and Windows 7, supports Linux 5 and 6 as well as Ubuntu, supports some of the recent Mac OS, it supports the iPhone and the iPad, the Android environments, and of course the Cisco IP phones. It also supports things like Symbian if you have Nokia or other phones also support it. And so it's really important to understand this AnyConnect Network Access Manager is a replacement for the legacy Cisco security solution. This is effectively a VPN solution, so it creates a private tunnel between the device and your appliance, your security appliance. And so it can use a range of different authentication protocols, including Radius. If you've got the Microsoft Active Directory, it'll support that. You can have digital certificates, as well as supporting LAPD, the Lightweight Directory Access Protocol. You can even combine a digital certificate for the device with a username password authentication, and therefore authenticate both the device and the user. It supports encryption AES 256, and if you did want, you could use the 3DES encryption as well. forming the VPN tunnel. It's got a range of different protocols that it can support, so you, depending on your network preference, you can use DTLS, you can use TLS, and it basically will automatically adapt that tunnel based on the network constraints that are currently operational. An AnyConnect client can connect in a few different modes. It can be standalone, which means you don't need a web browser, and you just install the AnyConnect client software permanently on the device. And if it's something like a Windows environment, you could just have an icon on the desktop which they can then just click in order to connect. You can even have the secure appliance, the ASA appliance, check that they've got the latest release of the client software installed and update it if it needs to be. Or you can come in through a web browser where you just enter the URL of the security appliance. There may be some circumstances where somebody wants to come in through a command line interface rather than a graphical user interface. So for instance, if you're running a Windows environment, you could just bring up the command prompt and then run the AnyConnect VPN client software. Similarly, you can do that in Linux and in a Mac OS environment as well. Of course, if you can go in through the command line interface, you can also write an API and initiate it with a customized application. So what you should be taking away from this is that the AnyConnect software is very flexible in terms of whether you deploy it on the client. When they connect, you then force them to connect through a secure VPN tunnel. You've got lots of capabilities where administrators can trigger a script to run when they connect, or to fully customize it and send messages down to the client to say you're now connecting to the corporate network. You've got the security head end that actually provides the firewall and protects your corporate network against any viruses and can monitor the traffic that's coming in through that connection. So it really is an interesting, nice, secure solution for mobile devices that are now connecting to the network over our Wi-Fi networks. To get the AnyConnect Secure Mobility Client software, you can download it from Cisco.com, and as with all of their software, you do need a service support agreement, like a SmartNet contract. You can actually get software from the App Store as well as the Android market if you're running an Android or an iPhone, iPad, Apple device. And just as an FYI, the AnyConnect Secure Mobility Client works well with the ASA 5500 series security appliance. Does not work with your older PIC security appliances, so just bear that in mind if you're deploying it. So in this lesson we're going to talk about the Cisco Compatible Extensions program, which is actually part of the Cisco Developers Network program. And what it does is it makes sure that features on the client are certified by Cisco to work with Cisco equipment that's deployed in the network, i.e. access points, wireless LAN controllers, the wireless control system. Now, once you've had your product tested to work effectively with the Cisco products, then you actually get the logo they're showing here, the Cisco Compatible logo. And the way this works is it's actually a no-cost licensing program, and the vendor will submit their wireless product to an independent lab such as App Labs, and they actually then undergo the testing. Now, if you do this, then you can take advantage of the Cisco advanced features that go above the Wi-Fi standards that the Wi-Fi Alliance tests for, and they would include things like security, some mobility features, quality of service, network management. Now, Cisco's compatibility program follows a specification, and so there's several releases of the specification that just builds and adds additional new features. There's version 1 through to version 5. And you would look at those versions and look at the specific features that you want. And the way to think about it is each specification builds on the earlier specifications and adds additional feature support. And here in this diagram you can see some of the features for release 1, 2, 3, 4 and 5, and you can see that I'm adding features as I go into the next release of the CCX specification. So version 1 is very much support of the 802.1x and has Cisco Leap support. Version 2 added compliance with the Wi-Fi Protected Access Specifications WPA and included TKIP. Version 3 then added WPA2, and you now see the support for the Advanced Encryption Standard AES, as well as 802.1x authentication type EAP Fast. Version 3 also included support for the Wi-Fi multimedia, which is your quality of service over a Wi-Fi network. And those features continued in 4 and 5. Here you can see that Cisco's added additional authentication methods with each release. And right at the bottom of this slide, you'll notice that release 5 actually introduce management frame protection, and this is where you encrypt the MAC header information, so somebody listening over the air can no longer determine MAC header information such as client and destination source MAC addresses. Version 2 of the specification started to introduce fast secure roaming through the 802.1x key management protocol, so you could pre-authenticate at the access point ahead of actually roaming to the access point. Version 3 introduced EAP Fast, and then you see the introduction of PEEP with version 4. PEEP setting up a secure tunnel ahead of actually exchanging your authentication information. On the quality of service side, version 1 had support for multiple SSIDs tied to multiple VLANs, and you see version 3 with the Wi-Fi multimedia, the Wi-Fi Alliance certification program coming in there, and then you see in version 4 the introduction of call emission control and expedited bandwidth request, which were two enhancements that were defined in the 802.11e specifications but weren't included in the Wi-Fi Alliance certification specs. Version 2 introduced the RF scanning and the ability to send that scanned data into the network where it can be analyzed, and the system will look for things like intrusion detection. It'll help with detecting interference sources, etc. Version 4, you get the UPSD, which is the power saving mechanism in a quality of service environment. You also start to see VoIP metrics coming into play to report on how to optimize a wireless LAN voice over IP connections. And you also start to see location tagging coming in version 4. Version 5 is bringing in some performance and also some troubleshooting techniques, which is extremely valuable for helping to diagnose what is happening on the client. So thank you very much for listening.